Alright, so now we're going to graph sine and cosine, and then actually write the equations from the graph. So, starting with sine, the first thing you should do whenever you're graphing is figure out what the midline is, because that changes where your function starts. So instead of graphing everything on this x-axis, I'm going to move everything down one, because this says that my midline is y equals -1, because that shifts the whole function down one. So I'm going to draw my midline. Then I need to make my 1, 2, 3, 4 tick marks for my 5 different significant points. And I need to figure out what the period is. So the period, if you remember, is found by 2 pi over b. And b is whatever's in front of theta, or x. So to figure out the period, I would do 2 pi divided by 6. Excuse me. Because that's what's in front of x. So 2 pi divided by 6, I can reduce this fraction to 1/3. So this is 1 pi over 3. And that's where the period ends, pi over 3. So now, you only have to label a halfway tick point, and that would be half of pi over 3, which is pi over 6. Half of 1/3 is 1/6. Okay? The amplitude comes from here. That tells me how far away the highest point, my maximum, and how far away my minimum is from the midline. So the amplitude is 2. So sine starts at the midline, and then the next significant point, since I'm in the middle, would either be a maximum or a minimum. And it's a maximum because that's a positive 2. So it would be 2 away from the midline because of this. And then, so naturally, once you go up, the next place to be would go down. But in order to go down, I have to cross my midline next. And now I'm going to go down to my midline, I'm sorry, my amplitude from my midline, which is -2 away. That's my minimum. So naturally, I'm at the bottom. My next step is going to be to go up, and I have to hit the midline in order to go up. So that should be the next significant point. And then again, I don't care that the pattern is consistent beyond that. This is one cycle. So we also need to find the domain. And the domain of this, it's going to continue. So like this cycle starts on the left forever and continues on the right forever. So the domain is -infinity to +infinity. Or if you write it in the other notation, x for all my x's is all real numbers. My range is my y values. So like the down to up. So this doesn't get any lower than this tick mark right here, which is -1, -2, -3. And it never gets any higher than this tick mark right here, which is +1. So the range is from the lowest first, -3, to +1. And then if you wrote it in the set notation, y for all my y's are in between -3, less than or equal to y, less than or equal to 1. So I'm going to do the same thing with cosine. First I need to figure out what's my midline, and it's been shifted up 1, 2, 3, 4. So I'm making my midline at y equals 4, because this has been shifted up 4. Alright, midline y equals 4. Now I'm going to figure out my period, because I've got one, 2, 3, 4. I always make my tick marks on the period. I don't know, that just helps me. So I need to figure out what the period is. And remember, period is 2 pi over b, and b is what's being multiplied to x or theta, and this is a 1x over 3. So b is 1/3. So in my calculator, I'm going to type in 2 divided by 1/3, and when I do that, I get 6 pi. So the end of my period is 6 pi, so the middle of my period would be half that, which is 3 pi. amplitude tells me how far away my min and max get from my midline, and there's a 1 here. So the amplitude is 1. This negative out front means it's reflected, so that means cosine usually starts at a maximum and then hits the midline and goes from there. But because there's a negative here, it's going to be reflected, so I'm going to start at a minimum. And it's only 1 away from the midline because the amplitude is 1. So I'm going to, if I'm at a minimum, my next logical step would be to go up. So in order to go up, I have to hit the midline and then hit a maximum 1 away from the midline. And then if I'm up, my next logical step is to go down. So in order to go down, I would have to hit the midline again and then go down at my minimum here. And then that's 1 cycle. And again, I don't care that it's accurate beyond that. But it does continue the exact same cycle. So the domain for this is the same, negative infinity to positive infinity, because it still continues left forever and then right forever. And the range for this is my y value. So the lowest the function goes is at 3, and the highest on the y-axis this function goes is 5, 3, 4, 5. So the range is between 3 and 5. Or you can write it for all my y's, y is in between 3 and 5. So now we're given the graph, and we have to come up with the equation that makes that graph. So sine starts at the midline. So what I do is I put my pencil on my endpoint here, and then I put my pencil on my endpoint here. And if that runs through the middle of my graph, not the x-axis, the middle of my graph, then that's a sine function. So this one is sine. This one, I put my pencil on my endpoint here and put my finger on my endpoint here, and when I put them together, it's running across the top, so that's cosine. If it was running across the bottom, it would be cosine, but if it's running through the middle, that means it's starting and ending on the midline, then that's sine. So I know that this is sine of x. I know that this is the midline. So the midline is right here, y equals 1. And the midline here will be in the middle. So it's y equals -2. So that I know I'm going to be subtracting 2 from the back. And here I'm going to be adding 1 to the back because of the midline. The next thing I can find is the amplitude. So the amplitude is how far away the min and the max are from the midline. So like if I count up here, this is 1, 2, 3. So the amplitude here is 3, and I'll check it on the bottom from the midline. 1, 2, 3. There's the minimum. So the amplitude here is 3. Here I'm going to count, and it's 1, 2, 3, 4. And just check here. 1, 2, 3, 4. So the amplitude of this one is 4. So you're just counting how far away it is from the midline. This one starts at the origin and goes up, so it's a positive 4. It's not been flipped. This one starts at a max, not at a min, so that's a positive 3. And then it's a y equals. The only other thing I have to deal with now is what's inside here. So what is the period? So the period of this function is 6 pi. Okay, and so to get that 6 pi, what I did was I took 2 pi over whatever's in front of this right here. So this is either a theta or an x, but I put 2 pi over whatever was in front of here to make this 6 pi. So I'm going backwards, and I'm going to call this b. B is whatever's in front of theta. So I know that 2 pi over b gave me 6 pi, so I need to solve and figure out what is b. So this 6 is not a fraction, so to make it a fraction, I'm going to put it over 1, I'm going to cross multiply. 2 pi times 1 is 2 pi. 6 pi times b is 6 pi. So I'm trying to figure out what this is, and that's b. So I'm going to get b by itself. I'm going to divide by 6 pi because it's being multiplied. Pi cancels. 2 over 6 is 1/3. So that means this is theta over 3. 1 theta over 3, 1/3. So that's the equation of that. And I can always make sure my graph's in radians, because these are in radians, and check it on my calculator. Alright, so here, I need to find out what this is. What's happening to theta. So again, the period of this one is pi over 4. And so in order to go the other direction, I took whatever's here, and I took 2 pi, and I divided 2 pi by whatever this is. So I'm going to call that b. So now I'm just going to cross multiply it. Pi times b is b pi, or pi b, equals 2 pi times 4, which is 8 pi. So I'm going to divide both sides by pi, because I'm trying to get b by itself. Pi cancels, and b is 8.